Hi students, it's me Harsnath Sukla, and today we are going to discuss revision lecture 6 for class 12th, where we have to study about the some questions based on properties of inverse trigonometric function. The first one is, so that tan inverse 1 by 2 tan inverse 1 by 2 tan inverse of 1 by 2 plus tan inverse by 2 by 11 is equal to tan inverse of 3 by 4. So see this question. The first one is LHS part we have to take and we have to solve RHS. So in this question, tan inverse 1 by 2 plus tan inverse 2 by 11, using the formula tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. So this is tan inverse 1 by 2 plus 2 by 11 divided by 1 minus 1 by 2 into 2 by 11. So this becomes tan inverse 11, 22 is the LCM. So this is 2 11, 11 plus 2 2s are 4 divided by 2 cancel, 1 minus 1 by 11. So this is tan inverse 11 plus 4, 15 by 22 divided by 11 minus 1 by 11. So this is tan inverse 15 by 22 divided by 10 by 11. 2 to the 11 to the 22. So this is nothing but tan inverse 15 by 2 by 10. So tan inverse 15 by 20. 5 3s are 4s are. So this is tan inverse 3 by 4, and this is your RHS. So in this manner we have to complete this question. So let us see again. Tan inverse 1 by 2 plus tan inverse 2 by 11. We have to use the formula tan inverse x plus y. So this is tan inverse x plus y divided by 1 minus xy, and we'll get the solution. Now next question. Next question is, write the following expression in its simplest form. That is, express the tan inverse cos x upon tan inverse cos x upon express the tan inverse cos x upon 1 minus sin x in its simplest form. So we have to see this question. We have to express the tan inverse cos x upon 1 minus sin x in its simplest form. So there are two methods, but we have to use the book method because it is easy to solve you, because you have to see from the book also. So tan inverse of, use half angle formula, cos square x by 2 minus sin square x by 2 divided by 1 minus 2 sin x by 2 cos x by 2. So we have to find it by cos x by 2 plus sin x by 2 within other bracket cos x by 2 minus sin x by 2, and this is nothing but sin square x by 2 cos square x by 2 plus sin square x by 2 minus 2 sin x by 2 cos x by 2. So this is tan inverse cos x by 2 plus sin x by 2 within other bracket cos x by 2 minus sin x by 2 divided by cos x by 2 plus sin x by 2 whole square, and one power is cancelled by this. So this becomes tan inverse of cos x by 2 minus sin x by 2 divided by cos x by 2 plus sin x by 2. So this is the half angle formula. By that we have to solve up to here. After that we have to take cos x by 2 is common in each of them, numerator and denominator. We will get tan inverse of cos x by 2 is common, then this is 1 minus tan x by 2. Cos x by 2 is common, this is 1 plus tan x by 2. So this is cancelled out. Tan inverse of this is 1 minus tan x by 2 divided by 1 plus tan x by 2. And you know very well this is the formula for tan pi by 4 minus x by 2. Tan pi by 4 minus x by 2 is nothing but tan pi by 4 minus x by 2 is nothing but 1 minus tan x by 2 divided by 1 plus tan x by 2. So we'll use the formula. This is tan inverse tan of pi by 4 minus x by 2. So this is simply pi by 4 minus x by 2. As you know, tan inverse tan x is equal to x. Okay. So this is your simplest form for that particular question. In the same manner, we have to proceed to other questions. So please see. Write cot inverse 1 upon root of cot inverse 1 upon root of x square minus 1 in its simplest form. We have to write cot inverse 1 upon root x square minus 1 in its simplest form. So for that, let x is equal to sec theta or cosec theta. Why? Because if in square root x square minus 1, then you always considered x as sec theta or cosec theta. If it in root 1 minus x square, then you have to consider x as sin theta or cos theta. If it is 1 plus x square or x square plus 1, then you have to consider x as a tan theta or cot theta. So here we consider x as sec theta or cosec theta. But here you have to see one thing also, cot inverse is there. So it is better to that after solving this particular expression, this should be cot theta. For that, if you consider x as a sec theta, then downside it is tan, and afterwards reciprocal relation is cot theta. So you consider as a sec theta, it is better. So cot inverse 1 upon root of sec square theta minus 1. So cot inverse of 1 upon tan theta, and this is cot inverse of cot theta, and this is theta, and from this you know theta is equal to sec inverse of x. So this is sec inverse of x. But if you suppose cosec theta, then question is also question has to be solved, but there are some change. Suppose for this particular question, if we consider x is equal to cosec theta, then this is cot inverse 1 upon of root of cosec square x minus cosec square theta minus 1. This is cot inverse 1 upon cot theta. This is cot inverse of tan theta. So this is the problem, but we have to solve cot inverse. Tan theta can be written as cot of pi by 2 minus theta. So this is pi by 2 minus theta, and theta is what? Cosec inverse x. So this is pi by 2 minus cosec inverse x, and you know the relation sec inverse x plus cosec inverse x is equal to pi by 2. So sec inverse x is nothing but pi by 2 minus cosec inverse x. So answer is same. Pi by 2 minus cosec inverse x is written as sec inverse x. So answer is same, but there are some difficulties. Okay. So now next question we have to see. Write the following function in its simplest form. Tan inverse root of 1 plus x square. Write in its simplest form. Question is tan inverse of root of 1 plus x square minus 1 divided by x for each x is less than 0. Sorry, each x does not equal to 0. So let us see this question. For this question, we suppose let x is equal to tan theta, then theta is equals to tan inverse of x. Why we suppose x is equal to tan theta? Because I already told you, whenever you see 1 plus x square or 1 minus 1 plus x square or x square plus 1, either in square root or simply you have to take x as a tan theta or cot theta. So this is the tan theta. So the expression becomes 1 plus tan square theta minus 1 divided by tan theta. So this becomes tan inverse of sec theta. Why? Because root of sec square theta, out of the root this is sec theta minus 1 divided by tan theta. So after solving this, 1 upon cos theta minus 1 upon sin theta by cos theta, it becomes tan inverse 1 minus cos theta upon cos theta divided by sin theta upon cos theta. Cos theta is cancelled out. So the whole expression is tan inverse of 1 minus cos theta divided by sin theta. After this step, we proceed as tan inverse of 1 minus cos theta is 2 sin square theta by 2, and sin theta is 2 sin theta by 2 cos theta by 2. You know very well this is the half angle formula. So sin theta is cancelled out. So this is tan inverse 2 cancelled out, sin theta by 2 divided by cos theta by 2. So this is tan inverse tan theta by 2. This is tan inverse of tan theta by 2. So this becomes only theta by 2 or 1 by 2 theta or 1 by 2. And what is theta? Theta is tan inverse x. So this is the 1 by 2 tan inverse x. This is also a very important question, and this is very useful to differentiate the function. That is, whenever you understand, whenever you study the differentiation of inverse trigonometric function. So these questions are very useful for that. Okay, now next one. Next question is, this is also a very good question. Cot tan inverse A plus cot inverse A. Find the values of following. You have to find the value of cot tan inverse A plus cot inverse A. See, this is very good question. Cot tan inverse A plus cot inverse A. So see, this is supposed to be cot tan inverse A. So this is the problem for the students. So if we put here tan inverse A plus cot inverse A, because you know tan inverse x plus cot inverse x is equal to pi by 2. In the same manner, this is cot of pi by 2 and cot pi by 2, you know the value of cot pi by 2. Tan 90 is infinite, then cot 90 is 0 only. Okay, so next question. This is also a very important question and many times asked in the board. This is the inverse trigonometric equation. So let us see. Find the value of x if tan inverse of x minus 1 divided by x minus 2 plus tan inverse of x plus 1 divided by x plus 2 is equal to pi by 4. See, this is a very good question. Many times asked in the board, but in different manner. So for that, you have to solve this equation and get the value of x. For that, use the first tan inverse x plus tan inverse y. Formula is tan inverse x plus tan inverse y is equal to tan inverse of x plus y upon 1 minus xy. So what you will get? You will get tan inverse x minus 1 upon x minus 2 plus x plus 1 upon x plus 2 and divided it by 1 minus x minus 1 upon x minus 2, 1 minus x minus 1 upon x minus 2 within other bracket x plus 1 upon x plus 2, and this is equal to pi by 4. Tan inverse is transfer here, then it will be, and here LCM is x minus 1 x plus 2, then it becomes x minus 1 into x plus 2 plus x plus 2 into x minus 1 x minus 2 plus x minus 2 and x minus plus 2 is the LCM. So if you divide it by x minus 2, x plus 2 will get x minus 1 into x plus 2 and again x plus 2, then x minus 2 into x plus 1. Okay, x minus 2 into x plus 1 and the whole divided by x square minus 4 as you multiply it minus x minus 1 into x plus 1, and this is equal to tan pi by 4, and tan pi by 4 is equal to 1, so this is equal to 1, and here x square plus 2x minus x, this is x, and minus 2 plus x square minus 2x plus x, that means minus x minus 2, and divided by x square minus 4 minus x square minus 1. So after solving the whole expression, we will get x cancelled out, 2x square minus 4, 2x square minus 4 divided by x square is cancelled out, minus 4 plus 1, this means minus 3, and this becomes x square cancel, minus 4 plus 1, this is your minus 4 plus 1, 3, minus 3, and this is equal to 1. So 2x square minus 4 is equal to minus 3. So 2x square is equal to minus 3 plus 4. 2x square is equal to 1. X square is equal to 1 by 2. So x is equal to plus minus 1 upon root 2. So this is the value of this particular question. That means is this inverse trigonometric equation. So thank you for today. We shall discuss the next questions in next lecture. Thank you.